Welcome. In this video, we are going to take a look at problem 42. It is from chapter 4 of College Physics 2E by Openstax. All right, and so we have a person being pulled away from a burning building, and we need to calculate the tension in the two ropes, and the person is motionless. All right, and we need a free body diagram. All right, so let's start with making a list of what we know. And so I'll write that over here. We know the mass of the person is 76.0 kilograms. We know the angle associated with tension 1 is 15 degrees, so we'll call that theta 1. 15 degrees. Okay, we know the angle associated with tension 2 is 10 degrees. We'll call that theta 2. And that is 10 degrees. And then we know we're looking for tension 1. And we're also looking for tension 2. Okay. And we know we need a free body diagram. So let's draw our free body diagram. Okay, and so we'll need our coordinate system. There's our positive x and y. We'll put the person as a dot in the middle. Okay, we've got a tension 1 going off like this. And we've got a tension 2 going off like that, and then we've got a weight which is straight down. Okay, let's make right triangles out of the two tensions so that the two tensions are each the hypotenuse. So there's one triangle, there's the other. We've got theta 1 there and theta 2 there. And now we can add the x and y components of each tension. Here's the x component of tension 1 and the y component of tension 1. Here's the x component of tension 2 and the y component of tension 2. All right, so we're going to need to find those components of each tension. And so let's consider each of the triangles. And so for tension 1, if we take the cosine of theta 1, we're going to get the adjacent side, T1y, over T1. So T1y is T1 times the cosine of theta 1. All right, if we take the sine of theta 1, we're going to get the opposite side, which is T1x, over hypotenuse T1. So T1x is going to be T1 sine theta 1. All right, we'll do the same for tension 2. Okay, so we'll take the cosine of theta 2. That is going to be the adjacent side, T2x, over hypotenuse T2. So T2x is T2 times the cosine of theta 2. All right, we need the sine of theta 2. Okay, this is going to be the opposite side, T2y, over the hypotenuse T2. So T2y is T2 times the sine of theta 2. All right, so there are all of our components that we need, and now we can apply Newton's second law. Okay, so we can sum our forces in the x direction. The person's motionless, so there is no acceleration, so the sum of the forces is equal to 0. And along the x-axis, we have T2x pointing in the positive direction, T1x is pointing in the negative x direction, so we will subtract that one. And that's it for forces along x. So we can say that's equal to 0. All right, so T2x is equal to T1x. T2x is T2 cosine theta 2. That's equal to T1x, which is T1 sine theta 1. Might as well solve for T2, and we get T1 times the sine of theta 1 divided by the cosine of theta 2. So there's our T2. All right, now we can also sum the forces in the y direction. Again, this will also be equal to 0 as there is no acceleration in the vertical. Okay, we have a T1y pointing up, so that's positive. We have a T2y also pointing up, so we can add that one. Then we have the weight pointing down, so we'll subtract weight, and that's it for all the forces along the y-axis, so we can put equals 0. All right, so we can add the weight to both sides and replace it with mg since the weight is equal to mg. So we get T1y plus T2y is equal to mg. Now we can substitute for the y components. So T1y is T1 cosine theta 1. Adding T2y, which is T2 sine theta 2. All that's equal to mg. All right. Now we can substitute for the T2. Okay, so we're going to have T1 cosine theta 1 not equals, we're going to do plus T2, which is T1 sine theta 1 over cosine theta 2. We have to multiply that by sine theta 2. All that is equal to mg. All right, so now we can factor out a T1 since each term on the left side has a T1. We're left with a cosine theta 1 plus sine theta 1 sine theta 2 divided by cosine theta 2. And then that's equal to mg. All right, all we have to do is divide by what's in the parentheses. Do that to both sides, and we get T1 is going to be mg divided by cosine theta 1 plus sine theta 1 times sine theta 2 all over cosine theta 2. Okay, now we can substitute the values and find what T1 actually is. Okay, our mass was 76.0 kilograms. G is 9.8 meters per second squared. And now we're dividing by the cosine of 15 plus the sine of 15 times the sine of 10 divided by the cosine of 10 degrees. Okay, I did this computation and I got 736.2 newtons. And so to 3 sig figs, T1 will be 736 newtons. Okay, now we can use that to find T2. We'll do it over here. So now T2 is the 736 newtons times the sine of theta 1, and theta 1 is the 15 degrees, divided by the cosine of theta 2, which is the 10 degrees. I kept more digits in the calculator when I did this, and I found that computed to 195.5 newtons. And so to 3 sig figs, T2 is 196 newtons. And there we have it, the two tensions that we needed to find. Okay, I hope you found that helpful, and I'll see you in the next one.